Hi there! You heard about sea ice deformation, but you're not sure what it is or why you should care about it? I'm Luisa van Eibdel, a PhD student at the Alfred Wegener Institute, and I will introduce you to the concept of sea ice deformation, which is a really cool way to break the ice. Before I saw sea ice the first time, I thought it would look like lake ice, so very flat and ideal for some ice skating. However, sea ice looks completely different. As you see here on the background image, sea ice has a really heterogeneous topography, with flat areas like in the foreground, but also high ridges, as you see in the background, sometimes as high as 2 meters. And of course, there are also open water areas called leads. Sea ice deformation makes this originally grown flat surface to such a landscape of mountains and valleys. You wonder why is that? To understand deformation, it's important to remember that sea ice is in motion, driven by ocean currents and winds. This high-resolution model simulation shows the main transport paths of the sea ice from the Siberian coast towards Greenland. The motion of the ice is not always spatially uniform, but can result into collisions that form pressure ridges. At the same time, ice flows drift apart from each other, opening up a lead. Those cracks that are well visible in this high-resolution model simulation strongly shape the appearance of sea ice. Let's zoom into one of those active zones. This schematic shows sea ice deformation in a nutshell. Whenever sea ice moves apart from each other, called divergence, a lead forms. Do you see the dark line in this picture next to the ship? That's such a lead. When the sea ice moves towards each other, the ice breaks and a part of the ice is pushed on top or below the other ice floes. This way, a pressure ridge forms. Look at this picture, how this looks like in reality. So now that we know what sea ice deformation is, we can move onwards to understand why it is so important for the polar climate and ecosystem. Have a look at the left corner, where a lead has formed. Because thick ice is a good isolator, there's almost no heat exchange between the warm ocean and the cold atmosphere. A lead acts then like a motorway for heat, but also for gases like water vapor and CO2, and creates a transport route from the ocean to the atmosphere, and vice versa. A large portion of those quantities is exchanged in those really narrow open water areas in winter. Another side effect of the isolation of the ice is that ice grows slower and slower the thicker the ice is. That's why most of the new ice forms at places where the ice is very thin, for example in leads. In winter, leads are therefore real sea ice production factories and increase the total sea ice volume. When new ice forms, there is a lot of brine released, so the salt that was not incorporated into the newly forming ice. This has a strong impact on the density of the ocean water below, and hence the general ocean circulation. The dark leads are also locations where during polar day sunlight can be absorbed. It is then available for the microorganisms living under the sea ice. Pressure ridges act like mountains. On the sun-facing side, more sunlight is absorbed, while on the shadow side there is less. Let's move over to the ridges. Since the ridges are not massive but consist of many loose blocks of ice that are somehow a bit connected, there are many void spaces. In those void spaces, smaller organisms can hide, find shelter, or simply have a surface which they can attach to. Therefore, ridges provide an important habitat for biota. Ridges are also obstacles for moving air and water. They create turbulence and increase the ocean and atmosphere drag. This way, they change, for example, how effective the wind can push the sea ice. You can think of ridges like sails in the wind. And lastly, sea ice thickness is changed by deformation. In leads, ice thickness is reduced, while ridges have often multiples of the original ice thickness. So, since the ice thickness is such a key property for many processes, this has numerous effects. In short, sea ice deformation is relevant for many aspects of the Arctic climate and ecosystem. Therefore, we monitor it closely with satellites and buoys. If you want to know how this works, have a look at the next video.